Welcome back to Mystery Suda's math videos. This video is continuing our discussion on the law of sines, but with the law of sines, you can be given three pieces of information to a triangle. You could be given a side, and then an angle. And what that does for you is it creates this scenario called the ambiguous case, meaning that with these three pieces of information, two sides and an angle, you could actually end up having two triangles that have those three pieces of information. And so it creates this scenario. Well, do I have a triangle, one, or do I have two? And that really can happen when it's going on. So the ambiguous case will occur when the given information, first and foremost, right, the given info about a triangle, when you're trying to solve for this triangle, the given info will be a side, then another side consecutively, and then an angle after. And so let me just give you a picture. Let's say it's this angle that's given, it's angle A. Then the sides that are given would be, let's call this B and call this C. So the sides that would be given would be opposite angle A, so side A, and then either side B or side C, so we'll just roll with that. So essentially what you can see here is that you'll be given the opposite side, and you'll be given the adjacent side, we can call it, right? So adjacent to that angle. But notice that it's in a row here, that it goes side, side, and then the angle. It's not the angle created in between, right? If it's the angle created in between, it would become a whole different kind of problem, and you would have to use the law of cosines. So it's side, side, angle. When that happens, you have this opportunity to where you can actually create two triangles. For example, you could say that you have something where you have your normal angle A, side A, and then call this side B, right? And we'll say that's the information given. But what could happen then is side A could swing in, and then you could essentially get, with the same three pieces of information, oh, I drew that a little wrong. Right, with the same three pieces of information, you could have a triangle that would look like this, and this would be angle C, and this would be B, but side A would be the same length, and B would be the same length, but side C would be the one that's changing, and so this side A would kind of swing in and be able to create two triangles, and that's when the ambiguous case will occur. So first thing, it's going to be created when you're given side, side, angle, and then there's a couple things that you can help memorize or learn so that you know what scenario might happen. So we're going to start with the scenario where you are given an obtuse angle. Okay, so let's say that this is an obtuse angle and you know angle A. And then the opposite sides that you're given, and I'm just going to say these drawings are not drawn to scale. Let's say you have the opposite side that's given, side A, and then we'll call that angle B, right, and side B. So let's say that we know angle A, side B, and side A. If the angle is obtuse, right, so if angle A is obtuse, meaning greater than 90, right, that's what that means, greater than 90 degrees, then here's how you can tell what's going to happen. If you're given side, side, angle, if the opposite side, right, if the opposite side is less than the adjacent side, okay, then what's going to happen is there will be no triangle. Okay? And the reason being is, if you picture, say you have like 100 degrees, right, say this is 100 degrees, and then this side, the adjacent side, is like 10, and the opposite side is only 5. Okay, well, you need it probably to be bigger than 5 in order to connect it all the way to the third side. So if the opposite side is less than the adjacent side and the angle is obtuse, you automatically know it won't create a triangle. if the opposite side is greater than, whoops, incorrect, right? If the opposite side is greater than the adjacent side, then you're only going to get one triangle. It won't have the opportunity to create two triangles. So those are two scenarios that you can just kind of learn, scenario number 1 and scenario number 2, when the angle is obtuse. So if, first off the bat, this ambiguous case that we talked about, having the potential of having two triangles, well, if the initial angle is obtuse, then you won't even have the possibility for two triangles to occur. It will only either be no triangle or one triangle. Okay? The second scenario, let's go with acute, right? So if it's acute, then that means the angle given to us is going to be less than 90 degrees. And we'll call that angle A. And so that means that's side A. We'll call this B, and let's call this side B, and side angle C, and that would be side C. So let's say that you're given angle A, it's acute, you know side A, and you know side B again. Let's say that you know angle side side or side side angle, however you want to say it. Those are the three pieces of information. Well, in that scenario, you're going to have two options again. Okay? So either the opposite side can be less than the adjacent side. So if the opposite side is less than the adjacent side, what will happen is you'll have this scenario where you can either have 0 triangles or 2 triangles. Okay? So scenario number 1, if the opposite side is less than the adjacent side, you'll have either 0 or 2 triangles. Number 2 would be obviously if the opposite side is greater than the adjacent side. And if that's going to happen, then you're only going to have one triangle. Right, so one triangle. So notice a couple similarities. Whether the angle is obtuse, right, obtuse, or acute, look at situation number 2. If the opposite side is greater than the adjacent side, you automatically know that there's only going to be one triangle. Not going to be anything else. The scenario happens is when the opposite side is less than the adjacent side. That's when we will have no triangle, or if it's acute, you'll have 2 triangles potentially. All right, so we're going to go through a couple things. We'll go over the scenarios of 0 triangles, like no triangles, or 2 triangles. If you want to know how to solve for just one triangle, go back and watch the first law of sines video on my channel, and you should be all right. That should help you find one triangle. So here we go. No triangle. I'm already telling you it's not going to have a triangle. Let's see how that occurs. So as I said in my last video, first thing, I'm going to draw a picture since there isn't one. So as we go to draw this picture, I'm just going to draw a triangle. Notice angle A is acute. Right, A is here. I'm going to put that there. That's 62 degrees. I'm going to call this angle B. I'm going to call this angle C. Okay, so I know angle A is 62, side A is 10, and side B is 12. So take a look at what we've got, right? We've got angle, side, side, or side, side, angle, and there's our 3 pieces of information. So in solving for a triangle, we're trying to find the missing angles, right? And we're trying to find the missing side, side C. And so we know angle A. I'm trying to find angle B, right? 62 degrees. I need this. I need angle C. And I'm trying to find side C. So I know side A is 10, side B is 12, side C, looking for it. So we're going to set up a proportion. And hopefully you have a calculator. And make sure it's in degrees, but here we go. So what is the only thing I can solve for? Honestly, the only thing I can solve for, if you're decent at the law of sines so far, is you're looking right here. I know angle A and side A, and I know side B, so the only thing I can find is angle B. So we're going to go with the sine of 62 over 10 equals the sine of b over 12. All right? I'm going to multiply by 12 on both sides, so I'm going to have 12 sine of 62 over 10 equals sine of b. And remember, if you're going to find the inverse function, or excuse me, if you're going to find the angle, you're going to need to use the inverse function. And so I'm going to do the inverse sine of 12 times the sine of 62 over 10 in my calculator, and that'll tell me angle B. And if you put that in your calculator right now, you can hit pause, type it in your calculator, and see what you get. If you come back with that your answer is undefined, right? You plug in your calculator, inverse sine of right, the inverse sine of b, or excuse me, 12 times 6 sine of 62 over 10 is undefined, then that means b is undefined, right? Which means we can't find an angle for it. So real quick, I'll give you the quick version. Since b is undefined, that means that the three pieces of information that we got in the original, right up here, that means that they don't create a triangle. And so there would be no triangle. So we would just say no triangle exists, right? Now, just a quick lesson on inverse functions. How do I know that this won't exist? Well, if you were to take, as I'm circling the inside of the inverse sine, if you were just to take that and evaluate it, it's going to be greater than positive 1. And the inverse sine has a domain between 1 and negative 1. So you can't plug in a ratio greater than 1 into the inverse sine. And so since that's bigger than 1, I know that there's no triangle that's going to exist. All right? So it'll actually be really apparent if no triangle exists. Your calculator will just hit you back with an error. It'll say undefined. Like, so if your math is good and you do everything right, then when you try to find that missing angle, it will just say no triangle. So that's really easy. You don't actually have to memorize that necessarily. You just start solving, and when it doesn't actually solve for it, you just say, hey man, no triangle. All right? Next one. This one's going to have two triangles, and hopefully it makes sense. All right? So we're actually going to just kind of go the same route. We're going to draw a picture. All right? So I'm going to call that C. That's 31 degrees. I know that this is 29. We'll call this B. We'll call that A. B is 46. So take a look at what we've got, right? We've got an acute angle right here. We've got this side and this side. This is the opposite side, and this is the adjacent side. And if you go back and look at your notes, this is what I was talking about, is that the opposite side is less than the adjacent side, and you have an acute angle. So if that's going to happen, I automatically know one triangle is not even an option. It's either going to be 0 triangles, like our calculator will tell you that nothing exists. It's either going to be 0 triangles, or it's going to be 2 triangles. It's just that one triangle won't be an option. Okay? So we automatically know going into this, this is either going to have 0 or 2 triangles. Okay? So what do? Well, you just start solving, honestly. You just solve it like normal. So you're going to set up a proportion, right? Set up a law of sines proportion. All right, so here we go. We're going to do the only thing we can do, which is we're going to find angle B, okay? That's the only thing I can find. So sine of B over 46 equals sine of 31 degrees over 29, okay? So we're going to multiply by 46 on both sides. Sine of B equals 46 sine of 31, okay, over 29. And then I'm going to do the inverse sine. So B equals the inverse sine of 46 sine of 31 over 29. Go ahead, hit pause on the video, plug it into your calculator, okay? Make sure you're in degrees, right? If you're not in degrees, we're in total trouble and we won't be able to do this very well. But if you plug it in correctly in degrees, you should get something that's roughly, right, roughly 54.78 degrees. Okay, so what does that mean, right? Well, that kind of goes with this. My picture looks gross, but you're saying, okay, 54.78, not drawn to scale, but seems like it would go right there. That seems okay, okay? But that means there's actually two triangles. Since we found an actual angle for B, there's not no triangle, there is actually two triangles. So let me give you a picture of your two triangles. So the first one that I drew is kind of a good sketch of it. Okay, so here's your angle C, right? 31 degrees. We just found angle B to be 54.78. Okay, and here's angle A that we can find now by adding those two together and subtracting from 180. But this is 46, and this is 29, and this is, we'll call it C1. Okay, but now there's a second triangle that's created, not with the angle of 54 degrees. What this tells me is that this is triangle 1, okay? Triangle 2 will look something like this. It's rough sketch, okay, not perfect, but here you go. We're going to call this 29, and there you have it. So here's angle C, 31. Okay, here's angle A, don't know it. Here's angle B, you actually don't know it. We'll call this A2, we'll call this B2, okay? And then you still know that this is 29 across from C. Across from B is still 46, but now you have different angles for B and A rather than that. So there's your two triangles. So if you could picture 29 degrees swinging in, or 29 degrees, the side length of 29 swinging in, that would swing in and make this second triangle that I've got here, okay? And that's what this guy is there. So that's your two triangles, okay? So how do you go about finding B2? So consider this to be B1. How would you go about finding B2? Pretty easy. They're just supplementary angles. So to find B2, I would do 180 minus B1. And so if you do supplementary, right, angles, you're going to subtract from 180, and for B2, we should be able to say that that would be 125.22 degrees. And they'll always be supplementary. So now I'm going to show you what you should have. So I've got triangle 1 over here, angle A, right, angle B, angle C. Side A, side B, side C. Triangle 2, okay? You've got angle A, angle B, angle C, and side A, side B, side C. Here's the truth. The truth is this. The givens are the same in both, okay? So we're given angle C, right? That's 31 in both. We're given side C. That's 29 units in both of them. We're given side B. That's 46 in both of them. Okay? When we initially solved, right? When we initially solved, we found B1. So I'm going to put that in for triangle 1. That's 54.78. To find the other angle, right? So in this scenario is B, and we found B1, and now we found B2 by subtracting from 180. If it was initially you were solving for A, then A would be the thing that you subtract from 180. But we've got 54.78, and then B2 over here is 125.22, and we need to find angle A. Now that you've found your two missing angles, or your two angles, B1 and B2, I want you to treat triangle 1 now, this guy, treat that as its own problem and treat those. So you should solve independently now. Okay, You shouldn't try to make them go together anymore. That's done. That's done here when you find the first angle and you do the supplementary angle. Once you do that, you're good to go, and you should now solve them independently. Because think about it, you should be able to add, right? We should be able to add things together. 31 plus 54.78. When I add those together, angle A would be 94.22 once I subtract from 180. Same thing over here, B and C, we add 125.22 plus 31, and then when I subtract from 180, I would get 23.78 degrees. Okay? Now I found all my angles. I'm still treating them independently. For this last one, I've got to find side A. So I'm going to do the sine of 23.78 over A equals, and I can pick either one. I'm going to go with my given, sine of 31 over 29. And then that will, I can solve it and get A for right here. And then for this one, I'm not going to use anything from triangle 2. I'm going to only use triangle 1. So sine of 94.22 over A equals, and I'm going to use my givens again, sine of 31 over 29. And I'm going to solve for A, and that will tell me what A is. So if you plug them into your calculator correctly, you'll find that this guy is 56.15, and you'll find that this guy over here is 22.7. Okay, which now if you kind of do your checks of triangles, that would make sense. Notice angle A in triangle 1, right, is the biggest angle, and A ends up being the biggest side. Also over here, angle A is the smallest angle, and it ends up being the smallest side, which works out nicely. Okay, so to kind of recap, the real issue comes when you have an acute angle and the opposite side is less than the adjacent side. That's when you're either going to get 0 triangles or 2 triangles. Every other scenario is either 1 triangle or no triangles, and that will show up pretty apparently. So to kind of go back, make sure you kind of are familiar with these scenarios, and remember, it only occurs when it's side angle info that is given. That's what you start with, right? If side angle is what you're starting with, then that's where you're looking, right? You're looking at the angle, and then you're looking at the opposite side and the adjacent side, and letting those dictate kind of what scenario you're in. And if you can do that, you should be all right. If you're given angle, side, angle, only 1 triangle. If you're given angle, angle, side, only 1 triangle. It's when you're given side, angle, that's when you have to decide this scenario. Okay? Hopefully that makes sense. I hope you guys have a great day. Talk to you soon.